All right, welcome to another session of MLX Compare. Today we're working with a really interesting model. This is the Ornith 1.5 35 billion parameter large language model, but it's quantized down to 4 bits using MLX. That's max kind of equivalent of bare metal, and only 3 billion is active. So I'm expecting this to be a very fast model. In fact, its reputation is built off being very, very fast. Ornith was made by a company called Deep Reinforce based out of Santa Clara, and this model has a good reputation because it's one, very fast, and two, it uses what they call CUDA L1 and CUDA L2, which is essentially a reinforcement learning model that they created that kind of optimizes token speed. So it makes everything faster through the usage of this L1 and L2. And they derived a lot of their information from Quen 3, I think 3.5, 3.6, one of those. Either way, it's a Quen 3 family, and Gemma 4. So yeah, I expect that this will be really, really fast. Our query is going to be, tell me all about Tyrannosaurus Rex. This model is being run on this MacBook Pro with 48 gigs of RAM. And let's give it a look. Tell me all about Tyrannosaurus Rex. And let me turn on the activity monitor here for a second. Where is it? There we go. We are at 31 out of 48. So very healthy. And let's see how it goes. There we go. That's busy. This is a mixture of experts model, so it's already pretty fast by itself, but now it's made even faster with the reinforcement learning. So let's see how it's looking. I have this tokens per second visualizer. I've already set it to 80 because I'm expecting it to be faster than Gemma 4 and Quen 3.5, and well, those models were at 70, 60, 70. What's going on here? Seems a bit slow. Wow, look at that. Something is going on. There it is, it's spitting it out. Oh, that's a lot of memory. That's pretty fast. That is definitely faster. That's faster. It's definitely faster. This is 80, and I think it's similar. Go deeper into a specific aspect. It doesn't have those follow-up kind of questions. I'm just going to paste whatever it suggests. And while that's going, I'll have this running in the background so we can compare. That's faster than 80. Wow. I think it's actually faster than 80. I'll have to get the specifics on it. Let's see the data quality. Okay, it's got some movies, a symbolism, cultural facts. All right, not bad. What is this edit button? Oh, interesting, you can actually edit the results. Oh, cool. Let's see how it handles tooling. I'll pick up our trusty 18K 398 row 308. We have a file, an automotive file, 398 by 9. So let's see if it finds it. Find it. Let's take a look. Oh, that's Quen. Look at that. Changed. Let's make sure we're actually using Ornith. Okay. And then let's turn on the code interpreter. So we can actually execute the test. And let's see, activity monitor. Wow, that's fast. That's really fast. Did it get it? It did. 398, 9, means 23.5, 23, yeah, that's all correct. And the most frequently occurring MPG is 13. Nicely done. Wow. Let's see how it handles RAG. Actually, no, we do have RAG set up. The query that we have is to calculate self-employment tax. Let's see how it handles it. I'll paste this into Gemini. So yeah, calculate the self-employment tax for 87,432. The answer is 12353.75. Let me make sure. Sometimes Gemini gets wonky. Let's first see if it's the same. $12,347.06. That's the number that's correct. Why is Gemini showing me something different? That is odd. $87,432 times 0.9235 is 87. Oh, okay. So I think we have something different here. It's 9.235 as opposed to 923 here. Just let me calculate this real fast. Make sure it's correct. $87,432 times, I hate to say this, but Gemini sometimes hallucinates. It hallucinates a lot more than these local language models. Okay, at least that calculates a property. So if you take off the 5, it's 8699.36. So, okay. It just used something, it added this 0.5 in the back. Okay, everything else seems kosher. Okay, so not bad at all. The last thing I wanted to test is to go back to the CSV file and have it tell me are there missing values. And typos are fine. I wanted to see how it handles typos. Yeah, definitely faster than 50, 70 something, I'd say. Okay. All three records have complete data with no missing values. Oh, but look at that. It's only saying it shows 3 sample records, while the full file contains 398. Yeah. So I think what's happening here is we have a memory issue, and it is only looking at 3 sample records as opposed to the entire data set. While I'm not happy with that, I am happy that it did tell me that it was doing that. I understand why that happens because we have memory constraints, but I'm grateful that it tells me that it only judged it off of 3 because the data is correct. The answer is correct, but it based it off of 3 sample records, right? Now the result is the same if you did the whole data set, but it's just lucky, right? It's lucky that it happens to be that way. Anyways, overall, this is it's a nice model. I'm actually very happy with it. I can't wait to do the test over on the Spark, and looking forward to testing the 9 billion parameter model. But yeah, really happy. Ornith 1.5 35B, 3 billion parameters active. Thanks a lot.